Okay, welcome to bonding review. Let's make sure we have our periodic tables out, reference tables, and shouldn't really need a calculator, but you never know. All right, so here we go. Given the balanced equation, an I plus an I yields I2. Which statement describes the process as represented? So first of all, these two I's are now bonded, so a bond is formed. Whoops. So when you form a bond, energy is given off, a sigh of relief, because now you have a stable electron configuration. Which kind of energy is stored within a chemical bond? Stored potential energy. A chemical bond results when two nuclei have simultaneous attraction for, well, electrons, choice 4. Now, in case you forgot, nucleons are anything in the nucleus. So what are the particles in the nucleus? Protons and neutrons. And those are those, and no. The elements Li and F combine to form an ionic compound. The electron configuration in this compound are the same as the electron configurations in atoms. This is a long way of saying we want to look like the noble gases, group 18. Which electron dot diagram represents H2? So first of all, hydrogen has one valence electron. So one hydrogen, another hydrogen, one from each. So I think these would not be easily chosen, but I think many students might choose one. Don't forget that each hydrogen brings an electron to the table. So number 2 is our answer. Based on your chemistry reference tables, which of these elements have the strongest attraction for electrons in a chemical bond? N, Na, P, and Pt. And of course, you're catching me without my reference tables. So let's see. Oh, and it's going to be like this. Okay, so N is 3, Na is 0.9. So hold on. 3.9. Phosphorus and platinum. Phosphorus is 2.2. Platinum. Where are you, platinum? 2.2. Wasn't phosphorus also 2.2? Yeah. Okay. Whoops. Nope. Sorry. 2.2. 2.2. Okay. So which has the strongest attraction for electrons? By the way, this is electronegativity. If you didn't know what I was looking at electronegativity on table S, which is choice 1. Nonmetals. But stronger of the nonmetals. Phosphorus is also a nonmetal. Okay, given the electron dot diagram, the electrons in the bond between hydrogen and fluorine are more strongly attracted to, well, first of all, they're going to be more strongly attracted to whoever has the higher electronegativity. So these can't be the choices. So who has the higher electronegativity? I know that fluorine is a 4.0, and I'm pretty sure this is 2.2, but let's just check, because, you know, I don't always remember. 2.2. There it is. Electronegativity. So, yes, obviously the higher number is the more electronegative. Which compound has the least ionic character, which means lowest electronegativity difference? I'm going to guess it's choice 4, simply because this is ionic, and this is ionic, and this is covalent. But what I would recommend you do is look up the differences and see whoever is the smallest. But just because it's so weird, you know, for me, I don't have a paper reference table with me right now. I would just have to go with that. 8 is 4. Okay. Greatest ionic character will be the biggest electronegativity difference. So we don't want anything covalent, which we don't have. Fluorine is 4.0. Oh, we just learned that N is 3. Na we learned earlier is 0.9. 0.9. So we need O, Ca, and Cs. O is 3.0. Calcium is 0.1. 1.0. This is 3. Chlorine is 3 point something. Sorry, you're catching me without my stuff here. Chlorine is 3.2. So 3.2. No, that's not it. Oops. Wrote it in the wrong one. 3.2 for chlorine. Oh no. I'm falling apart here. Pen. And this is not 3.2. Cesium. That's going to be way down. Way down on the periodic table. Cesium is 0.8. Okay, so if you go through and you do the differences, 4 minus 0.9 is 3.1. This is going to be a difference of 2. 3.2 minus 0.9 is 2.3. And 3 minus 0.8 is 2.2. So biggest difference is choice 1. Which compound contains both ionic and covalent bonds? So this means we have to have a polyatomic ion. Ammonia, NH3, methane, CH4, sodium nitrate, NaNO3, potassium chloride, KCl. So choice 1 is an covalent compound, molecular. So is this one. This is ionic. This has the covalent of the polyatomic, and you have the positive and negative charges going on. So choice 3. Which substance contains bonds that involves a transfer of electrons? It's ionic, which is metal and nonmetal. So the only one with a metal and nonmetal is choice 3. Which type of bond is found in sodium bromide? So sodium and bromine. So this is a metal and this is a nonmetal. So that's ionic bonding. Compared to a calcium atom, the calcium ion Ca+2 has, so protons are going to change because we're still dealing with calcium. So charges. How do you become positive? You're losing electrons, which are negative. So when you lose negatives, you become more positive. So we have fewer electrons. Choice 4. What occurs when an atom loses an electron? So when you lose an electron, much like when you lose weight, you get smaller, so your radius decreases. And when you lose electrons, you become positively charged because electrons are negative. In which compound have electrons been transferred to the oxygen atom? So transferred again means ionic. So oxygen is a nonmetal, so we need a metal here. Carbon is a nonmetal. Nitrogen is a nonmetal. Nitrogen is a nonmetal. Sodium is a metal. Choice 4. Based on bond type, which is the highest melting point, we want ionic bonding. That's just something we need to memorize. So covalent, covalent, covalent. And again, how do I know? Ionic is metal and nonmetal. If you're not as fast as me, you just go to the periodic table and you just take a look. Do we have a metal, which is on the left, with a nonmetal on the right? A substance that does not conduct electricity as a solid, but does conduct electricity when it's melted, is most likely ionic compounds. It's a straight up definition. A hard substance that has a high melting point and a poor conductor electricity in the solid phase could be, once again, ionic. So now we're looking for an example. That's a metal and nonmetal. Okay, so nope. This is just a metal, so that's not it, and not it. So choice 3. Given the formula for oxygen, what is the total number of electrons shared? So electrons, not bonds. So when we have this, that is 4 electrons, not 2 bonds. Be careful how to read it. Given the formula, what is the total number of shared electrons? Okay, so remember, on either end of each bond is an electron. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Which 2 substances are covalent compounds? So only nonmetals. So potassium is a metal, can't be that one. Choice 2 looks to be my answer. Potassium and sodium, both metals. Sodium is a metal. So no metals here. Choice 2. bond between Br atoms and a Br2. So here's Br2. 1, 2, 3, 4, 5. Normally would be like this, but of course if we're going to be doing a bond here, we're just going to flip that over, and then there'd be a singleton here. 1, 2, 3, 4, 5, 6, 7, and it would be shared. Bromine is a nonmetal, so they're going to be shared, and that is a definition of covalent. Covalent, which will have a double bond. This is just something that we need to remember. Oxygen, the picture is here. So oxygen is the double bond. Single, triple, single. Which atoms are most likely to form covalent bonds? Those are going to be nonmetals only that share electrons, not sharing protons. Which one do we have that share electrons? This is covalent, which is 2 nonmetals. So any metals be gone. Metal is sodium, metal is calcium, metal is magnesium. Now, where they're going to try to trick you is hydrogen. Hydrogen does live on the left side with the metals. However, it is not a metal. Which type of substance is soft, low melting point, poor conductor of heat and electricity? This is a covalent compound, which is called a molecular solid. Network solids are things like diamond and sand. Metallic solids, obviously metals. Ionic solids, table salts, other kinds of salts. What's the maximum number of covalent bonds a carbon atom can form? So 4 valence electrons, 4 bonds. Which substance has metallic bonds? So we want only metals. So there's nonmetals, there's a nonmetal, and all nonmetals. So metallic bonding happens within metals. This is the mobile sea of electrons. Conductivity, oh look it, there's choice number 29. Conductivity in a metal results from having a highly mobile electrons, the mobile sea of electrons. No. Which substance will conduct electricity in both the solid and liquid phase? So this is metals. Think about when you're making a grilled cheese sandwich, you want a solid metal pan that will conduct heat and electricity, but also you liquefy it, you put it into water, it's going to conduct. So we want simply a metal, which is choice 2. Which compound is a poor conductor of heat and electricity and has a high melting point? Poor conductor of heat and electricity with a high melting point. So let's see. This is a network solid because these are all molecular. This CO2, this is all low melting point. So this is sand, silicon dioxide. So it's got the kind of the combo. It's got the low conductivity, but of the moleculars, but it's got the high melting point of the ionics. Silicon dioxide and diamonds are best described as molecular substance. So, they are network solids with covalent bonding, so they're sharing. Molecular substances would be 2 nonmetals, and silicon is a metalloid, and diamond, although it is non-metal, it's not ionic and it's not coordinate covalent. The degree of polarity in a chemical bond can be predicted by determining the difference in the electronegativities, we've done that before, which contains a nonpolar covalent bond. So this means an electronegativity difference that is 0 or very small. So who's going to have the same? Well, if you look at choice 3, whatever bromine's electronegativity is, which I guess I can look it up. Bromine. 3.0. So this is a 3.0 and this is a 3.0. So when you subtract them, the difference is 0. All these other bonds are between 2 different atoms. So they're going to have some kind of a difference. That's going to be 0. The bonds between hydrogen and oxygen in a water molecule are classified as, well, those are 2 nonmetals. So they have to be covalent. So then we have to say, okay, what is our electronegativity difference? 2.2. I looked up oxygen before. 2.0. That's not right. Oxygen? 3.0. The difference. Okay, so when you subtract them, the difference is 0.8, which is in the polar region. Remember, anything 0.5 to 2 is going to be considered a polar bond. The electrons in a bond between two iodine atoms are shared equally or unequally. And what happens? Well, they're both iodine. So I'm going to give that I a hat just for kicks. I'll give them both hats. So whatever their electronegativity whatever it is, it's the same. So it's going to be shared equally. And we call that a nonpolar bond, meaning neither one is pulling harder. Which is most polar, which means the largest electronegativity difference. So hydrogen is 2.2. Cl we had before 3.2. Bromine, iodine. Well, I know fluorine, whatever these other ones are, it's not going to be as high as fluorine, so it's got to be choice 1. Polar molecules are asymmetrical, so draw them. I'll draw them over here. CO2 looks like this. So that's like this. Likes to double bond with oxygen. So when you see this, you say, okay, it's symmetrical no matter how I cut it. So that is called nonpolar. And HCl. Now that is asymmetrical. HCl is asymmetrical, but the CO2 is. So nope. So nope. So maybe choice 3, because I know HCl is polar. So H2O, oh look, it's right here. So cut it this way and it looks symmetrical, but cut it this way and it is not symmetrical. So this is our answer, choice 3. Let me get rid of this stuff here. Okay, at STP, fluorine is a gas and iodine is a solid. This observation can be explained by, okay, so what's holding a solid together is strong intermolecular forces. Average kinetic energy is temperature. That's not why. So weaker intermolecular forces. Hold on. Fluorine has weaker forces because fluorine is a gas. Yes. So make sure you, oh, whoops, I missed number 39. I'll go back to that. So make sure you read how it's talking, what it's talking about. Fluorine has stronger intermolecular forces. No, fluorine is the gas, which means the particles are just like, whoosh, they're going away. Liquid be sort of strong. Iodine and the solid be the strongest. Okay, so back to 39. Nonpolar molecule is symmetrical. So see how we have H2O like this? Oxygen is in the same group as sulfur, so it would look like that, which we just said would be a polar or asymmetrical molecule, so that's not it. HCl, I drew it before, but I'll draw it again. There's my bond. So that is asymmetrical. CH4, then you have the bond like this. So let's cut that. Looks symmetrical no matter how I cut it, so that is indeed my answer. Just in case you wanted to see, remember the lone pair repulses downward. So that looks okay, but that doesn't. So we're going with that CH4, choice 3. Sorry, this is messy. Number 41. So we've talked about it before. It is asymmetrical if you cut it like this. And asymmetrical by definition means a polar molecule. Which structural formula represents a molecule containing two polar bonds? So bonds. So between N and N, it's the same electronegativity, so that can't be it. So there's a bond here, which is the same as the bond here. And then we'd have this bond. But if you look, this orange bond here is two of the same, so that can't be it. And on that same note, since we're here, there's a C to C bond. And although all these red bonds might be different, but we've got a C to C, which it has to be a nonpolar. So this is a polar bond and this is a polar bond. There you go. One atom of A forms a coordinate covalent bond with an atom of B. Coordinate covalent bonds, if you want to look at 44, that is coordinate covalent bonds. So a lot of times you have like nitrogen where you've got this lone pair up at the top, where you think, okay, nothing's going to happen, but hydrogen ion has nothing. So normally there's a sharing where one from each comes together, but if hydrogen has no electrons and this has 2 electrons, then, well, how about we just have that nitrogen host that hydrogen right there? And that's how we get NH4 with an additional plus sign, which is called ammonium. So coordinate covalent bonding is, sharing. Well, first of all, it's not transferring. So I can get rid of that. Transferring is ionic bonds. Sharing 2 electrons belonging to atom A. Sharing only 1. No. So the whole point is that this has 2, this has none. So the sharing of 2, which is choice 1. Which molecule could form a coordinate covalent bond with a proton? So who has a lone pair just chilling out? Not this, not this. Look here. We've got a lone pair here and a lone pair here. That's how you get hydronium. These are all bonds, so that wouldn't work. Choice 3. The table shows properties of 3 solids. What is the correct classification? So if you look, X has a high melting point, solubility in water. Solid state does not conduct electricity. So this is very telling to me here. It's a high melting point, but it's not the highest, and the solid does not. So that means ionic here. In Y, look at this low melting point, not conductive at all. So this is a molecular. You'd accept molecular compound. We'd also accept covalent. And solid Z, really high melting point, doesn't dissolve in water, and solid and liquid. I think that's right. Yeah. Just doubting myself. Okay, so each molecule listed below is formed by sharing electrons. So we've got Cl2, CCl4, and H3. Explain why CCl4 is classified as a nonpolar molecule. Well, if you have no idea, draw it. So, and then chlorine will share here. Whoops. And then chlorine will have this. And chlorine. Now, don't forget, chlorine has 7 valence electrons, and then let's fill in my bonds. Do. So if we're looking for symmetry, you've got it. So it's nonpolar molecule because it is symmetrical shape. You can also say it has even bond distribution. You know what you can't say? The electronegativity difference is such and such, because molecule polarity has to do with symmetry. In addition to water disinfection, chlorine and its derivatives are used to treat sewage and industrial effluent, and as a household and industrial bleaches to maintain and improve hygiene standards. Draw the electron dot diagram for Cl2. So there was something to read, but it didn't really matter. So Cl and Cl. We just mentioned that chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7 is not going to work. Also, that got really messy all of a sudden. So I'm going to change this up. So singleton here. Singleton's in the middle. There you go. Draw an electron dot diagram for each. They were so nice to you. They told you that part A was ionic. So calcium oxide. Okay, 2 valence electrons for calcium. And those for the oxygen. So draw a transfer. Okay. Now, so that is A. And then hydrogen bromide. So this is a covalent. So 2 nonmetals share. And so is carbon dioxide. So share. HBr. I didn't fill it in the right way, but there you go. And then carbon dioxide is unique. I already had green. Carbon will be our central atom, which would normally look like this. However, carbon is bonding with oxygen, which likes to double bond if possible. So there's a bond there. bond. That's part C. Draw the structural formula for H2O. I don't like it says draw a structural formula. Just draw it, okay? Oxygen would love to double bond, but it can't with hydrogen. So you end up getting this bent shape with the lone pairs. Is this molecule polar or nonpolar? Explain. Looks symmetrical here, but not here. So the molecule is polar due to asymmetrical shape, asymmetry or asymmetrical shape, and uneven bond distribution. If you have any questions, let me know. Look at, here's all the answers. Look at that. Yay. If you have any questions, let me know. Thank you.